Greetings and welcome to Train Signal. You're watching How to Configure Enterprise Voice. In this video presentation, we're going to see how to configure Enterprise Voice. Everything from setting up dial plans, to voice policies, to routes and trunk configurations. Well, let's start off with our dial plans. Within the organization of Carve Rock Fitness, users dial all sorts of number strings. We dial 0 to get to operators. We dial 4-digit extensions to dial people internally. We also dial 7-digit numbers, 10-digit numbers, 11-digit numbers, and international numbers. When we dial number strings, Microsoft Lync is going to have to understand what those numbers are so that it knows how to translate them for authorization and call routing. The way that we do this is by creating dial plans. Dial plans define name sets of normalization rules that translate phone numbers over into an E.164 format. E.164 is an international numbering plan developed by the International Telecommunications Union. There can be a maximum of 15 digits in an E.164 number. So in theory, to direct dial from any conventional phone to another phone anywhere in the world, you would have to input no more than 15 digits. Let's take a look at an example of what this would look like. In this demonstration, we're going to see what the normalization looks like. And what I've done is connected over to my control panel. And inside of my control panel, we're going to click on Voice Routing. And you can see that this is where I have my dial plans located. I'm going to open up the dial plan for Scottsdale. And as I scroll down, you can see that I have the associated normalization rules that I have created. The normalization rules configure how the numbers that you dial get translated over to an E.164 format. So let's take a look. Here's a rule which I called Scottsdale Operator. And you can see the normalization rule. If you dial a number that is exactly 1 digit, and it starts off with 0, we're going to remove 1 digit, and we are going to append a plus 14805552000. So at the bottom of the console, if I dial 0 and click on Go, this allows me to test it with inside of my control panel. And you can see how that number got normalized over to that E.164 format. Here's another example where I have 4-digit internal numbers. If you dial an internal number that starts off with the number 2, and it's exactly 4 digits in length, we're not going to remove anything, but what we are going to do is append the plus 1480555. So let's dial the number 2000 and see how that translates. And once again, you can see another example of the normalization. You have to remember that when a client logs into Microsoft Lync server, the client will obtain its policies from the Lync server, and those policies will control how the numbers that a user dials get translated or normalized down on your client. Let's close out of the control panel. When we set up and define our dial plans can be applied at several levels within inside of the Lync product. The dial plan that would have the highest precedence level would be a user level dial plan. So if you have a dial plan applied to you as a user, well, that would have the highest precedence, meaning that's the one you would use. So when you log in and register to Lync, if there is a user level dial plan, that is the one that you as a client will be using. Now, if you don't have a dial plan applied to you as a user directly, we then look at the pool level. And if you don't have one at the pool level, your next choice would be site level. And the last case scenario, the lowest precedence, will be global. So if you don't have a dial plan applied at the user, the pool, or the site level, you get the settings from the global dial plan. As we set up our dial plans, one of the most important things is planning your dial plans. And planning of your dial plans can be very time-consuming in a large organization. We have to have a really good understanding of the locations within our organization and the different types of numbers that are being dialed by the individuals. Another great practice is to come up with dial plan naming conventions. It makes it easier for other administrators within your environment when they're looking at dial plans that follow a certain naming format, especially when you're the administrator that has to follow in somebody else's footsteps. So as we create our dial plans, a dial plan is going to be a combination of .NET Framework regular expressions, and they identify numeric patterns that your users are dialing and how they get translated or normalized over to an E.164 format. So when you dial a certain number string, the product understands that this matches a certain pattern and this is how I'm supposed to translate it. So as we create our normalization rules for the dial plans, you can create them inside of your control panel or through the Link Server Management shell. Let's take a look at a demonstration on configuring the Carvrod Fitness dial plans. So to configure a dial plan, I have to open up my control panel. We'll provide our credentials to log in. And then we'll click on Voice Routing. And as you can see, I've already created a couple of dial plans, one for Mesa and one for Scottsdale. To create a brand new dial plan, you would click on New, and then you choose the type of dial plan that you want to create. And you remember that the user dial plan has the highest precedence, followed by Pool, and then followed by Site. When you go to create your brand new dial plan, you have to configure a lot of properties. You have to provide a name for your dial plan, such as Scottsdale. Now, the global dial plan will be called Global, and your site dial plans will match the name of your site. User level dial plans, you can define whatever name you want. You can provide a description, which is optional. We also have a dial-in conferencing region, and this comes into play when you send off a meeting request. So if this were my dial plan, when I send off a meeting request, the first 3 telephone numbers associated with Arizona Scottsdale for dial-in conferencing would get sent along with my meeting request. We can also define an external access number. At the bottom of the console, you can see my normalization rules, and the normalization rules dictate how the number strings that we dial get translated over to an E.164 format. So if you want to create a new normalization rule, you click on New, and then you fill out the property sheet. If you're creating a dial plan and you want to use some of the normalization rules that you've already created for another dial plan, you just click on Select, and you can choose them from the list. Now let's take a look at a couple of normalization rules, and here's one called Operator. I provided the description Corporate Operator, and you can see down below that I have my normalization rule. So if you dial a number, it starts off with 0 and it's exactly 1 digit. You see you have other choices. And we're going to append plus 14809300100, which is the number of my operator over at Corporate in Scottsdale. Down at the bottom of the console, if you want to test this, we'll type in the number and click on Go. And you can see how the number got normalized. As another example, let's take a look at our Scottsdale 4-digit. We're using 4-digit extensions inside of our environment. So if you dial a number and it starts off with the number 1, and it's exactly 4 digits in length, we're not going to strip off any numbers, but we are going to append the plus 1480930. So let's give this a try. We'll type in 1000. And once again, you can see how the number got normalized. So here's one for Scottsdale local. If you dial a 7-digit number over in Scottsdale, exactly 7 digits, we're not going to strip off anything, but we are going to append the plus 1480. I've also created a normalization rule for international dialing. So here, if you dial a number and it starts off with 011, at least 5 digits in length, we're going to strip off 3 digits, but we are going to append the plus. And once again, translate that over to an E.164 format. So let's cancel off of this. And you can see how when you go through the process of setting up your normalization rules, or your dial plans, you would have to define this on a site-by-site basis. Now that we understand how numbers get formatted and translated by Link through dial plans, let's take a look at configuring voice policies. When a user registers with the Microsoft Link server, the user will have a voice policy assigned to the user through in-band provisioning, meaning the Link server will give you your settings when you connect and register. Voice policies control the features that you can use in the phone system, as well as where you can dial to through PSTN usage records. I think of voice policies kind of like permissions. They define the permissions for the features that you can use and the permissions for where you can call to. When we set up our voice policies, they can be applied at the user level, at the site level, and globally. Once again, the preference will be for the user level. So when you register as a user, if you have a user level policy, that is the one that you're going to use. You'll get the settings from that policy. If you don't have a user level policy, your next preference would be site level. And if you don't have one at either the user or the site level, you will get the settings from the global voice policy. When we set up our voice policies, we'll be able to determine which calling features our users have access to. So we can control whether the users can do things such as forwarding calls, using delegation, transferring calls, or even parking calls. The voice policies will also control the numbers that users can dial, or more specifically, where the users can call to. Voice policies will also have associated PSTN usage records inside of them. PSTN usage records determine where you can dial to, so they're number patterns that, if matched, will determine how a call gets routed. PSTN usage records determine whether you can dial locally, long distance, or even internationally. Let's take a look at a demonstration on configuring voice policies. In this demonstration, we're going to see how to configure voice policies from within our control panel. So once I've logged into my control panel, we'll navigate down to Voice Routing and click on Voice Policies. Now your voice policies can be applied at different levels, globally, at the site, and down to the user level. User or tag level policies have the highest precedence, followed by site, and followed by global. Now when you look at the properties for a policy, like my Mesa policy, you can see that we give it a name and an optional description, but then down below you can define your calling features and where somebody can call to. So do I want my users in the Mesa site to be able to use call forwarding? Can they use delegation? Can they transfer calls to other devices? You'll notice that Call Park is not enabled by default. Call Park allows a user to park a call on a temporary extension, freeing up your phone line. It's kind of like putting a call on hold, but it's not putting it on hold on your phone number. We can also enable simultaneous ringing of phones, so when a call comes in, the call can ring on multiple devices, like your portable phone and your desk phone. We also have Team Call, where we can go in and we can define team members, so calls coming in can ring on all the devices of the members of the team. We also have the ability to enable PSTN rerouting of calls that are getting prevented from going through because of call admission control and bandwidth management policies. If we enable bandwidth policy override on a user's policy, call admission control will not enforce bandwidth management on any incoming calls to that user's phone. We use this feature sparingly. We can also enable a feature called malicious call tracing, which allows a user to mark a call as being malicious at the end of the call. So if we get any threatening or harassing phone calls that come in, we can put an entry into the call detail records database. An administrator can track the call back to its provider and then take the necessary actions. You'll also notice at the bottom of the window that we have associated PSTN usage records. And these records define where you can call to. So just like we have calling features that dictate what features you can use, we also have permissions to be able to dial different types of numbers and to have those calls getting routed. So if I want to create a brand new PSTN usage record, you click on New, and then you give it a name and you define the routes that are associated with it. If you already have a PSTN usage record that you want to associate with this policy, you would click on Select and then select it from the list. Now that we have an understanding of voice policies, let's take a more in-depth look at configuring routes. Inside of Microsoft Lync, call routes specify how Lync server handles outbound calls placed by enterprise voice-enabled users. A user that is not enterprise voice-enabled cannot make a call beyond your corporate boundaries. So when you dial a number, the number gets translated over to an E.164 format based off of the settings of your dial plan. Once the number has been translated over to an E.164 format, Lync can then determine how to route the call. The first thing that Lync will do is it will try to match that dial string over to an internal SIP URI. We call that reverse lookup. Lync will next use outbound routing logic to determine which gateway to route the call to. So inside of your voice policies, we have PSTN usage records, And the PSTN usage records have different rules on how to route calls that match certain patterns. So once Microsoft Lync determines that we have an outbound route inside of one of our PSTN usage records based upon the match pattern, it then will determine which gateway to send the call to. A very basic concept for routing is defining least cost routes. For example, in our organization, we have gateways located in California, in Texas, and also in Arizona. So if a user in the organization places a call to a local number over in California, we'll pass the call over to the gateway over in California. Least cost routing. We're going to route the call as close to the endpoint as we can so that we don't get hit with long distance charges. And if one of our users in Texas places a call to a local number over in Arizona, we'll route the call over to the gateway in Arizona. When you define a route, you have to provide a name for your route. For example, Scottsdale Local or Scottsdale Long Distance. We also have the ability to provide a description, but that's optional. We then also define the regular expression or matching pattern and any exceptions for the rule. So when you dial a number that gets translated to E.164 format, the regular expression of your route has to be a match in order to route the call to the defined gateways. So we'll also define the gateway or trunk configuration that will be used with our route. So routes are associated with PSTN usage records, and PSTN usage records are associated with our voice policies. I know this sounds very confusing, but let's take a look at a demonstration on configuring routes. It's not as bad as it sounds. Let's take a look at setting up routing inside of Lync 2013. We'll start the demonstration by opening up the control panel and logging in as the administrator. From inside of the control panel, we'll click on our voice routing, and then we're going to navigate over to the route tab. Now, as you can see, I've already got a bunch of routes already predefined, but if you needed to create a brand new route, you can click on New, and then define your route settings. Let's take a look at my route called Mesa Local. Here you can see that I gave the route a name, and I've also provided a description which is optional. Now, as you define your route, you have to define a pattern to match. So when a user dials a number, the number will get translated over to an E.164 format handled by your dial plan. Here we're defining a pattern to match for the number after it goes through normalization. So if you dial a number that gets translated over to a string that starts off with +1928, this is the route that will handle that. Once your server determines that it has a pattern to match, it has to figure out which gateway to pass the call over to. And this is handled through your trunk configurations. Let's navigate down to the bottom of the console. At the bottom of the console, you can see that I have a couple of associated trunks. If you want to add a trunk, you would click on Add and then select it from a list. Now, we're going to see how to set up a trunk in the next demonstration. But at this point, keep in mind that a trunk will associate your mediation server with the gateways. It will also define which ports to use to communicate over with the gateway. We'll click on Cancel. But you can see that I'm using a couple of gateways. I'm providing an extra gateway over in Scottsdale for fault tolerance. By providing multiple associated trunks or gateways, it allows Microsoft Lync to load balance between the different gateways. So it provides me a higher level of availability because if one gateway is down, I can use the other. I can also define a preferred route by having multiple routes, with one route going to the preferred gateway and the second route going to an alternate gateway. You'll also notice that when I configure the properties for the route, we have the ability to suppress caller ID. So for example, if my company had an office that was international, maybe over in Europe, if the Europe office was calling numbers over in the United States, we may want to suppress the caller ID and provide a local number to the US. So not only can you suppress the caller ID, but you can also provide an alternate caller identification. At the bottom of the window, you can also see any associated PSTN usage records. A PSTN usage records defines where you can dial to on your voice policies. So from within my voice policies, you can define your routes right from inside of here, so both of these properties kind of tie into each other. So as an example, if I go to voice policies, and I look at Mesa, and then at the bottom of the console I see where I have my associated PSTN usage records, like Mesa Local. This PSTN usage record is defined by the associated routes. So here's where you can define your routes. You can select them from the list, and you can also create a new and define your new routes here. So just a moment ago we defined the routes on the Route tab, but you see that we can define them here inside of our PSTN usage records also. An essential component of defining routing with LINQ is defining your trunk configuration. In order to define trunks, we have to define them inside of our topology builder. We create an association between the mediation servers and the corresponding gateways that those mediation servers can use. We also determine which ports will be used to communicate over with the gateways. From inside of our control panel, we can configure the trunk configuration. Microsoft Link 2013 allows us to configure the calling number translation rules and called number translation rules. So we can translate numbers, the calling and called number, into a different format before passing the call over to the gateway. So it's possibly less configuration over on our gateways. So as a number gets translated over to an E.164 format from your dial plan, well, before the call gets passed over to the gateway, we can handle the translation once again. The trunk configuration in the control panel also allows me to configure settings such as, will my gateway support media bypass? Or does my gateway support referrals? A SIP referral is a SIP request, which is a code used by Session Initiation Protocol for communication. More specifically, it's typically used with call transfers. With LINQ Server 2013, we can have connections from our mediation server over to multiple gateways, and we can also have multiple connections over to the same gateway. So when we define our trunk configurations inside of the topology builder, it creates a logical association between the mediation server and the gateway, and the ports that we're using for sending and also for listening. When you're defining your routes inside of the control panel, you define which trunk configuration you're going to use. And behind the scenes, that's linked over to the mediation server that can send the call over to the gateway. So when we create trunks inside of our topology builder, it's defining the relationships between mediation servers and PSTN gateways, IP-PBXs, or session border controllers. A LINQ 2013 mediation server can use multiple gateways, and gateways can be used by multiple mediation servers. It's a many-to-many relationship. Let's take a look at a demonstration on configuring trunks. We'll see how to define our trunks in the topology builder, and we'll also take a look at configuring the settings inside of our control panel. In this demonstration, we're going to see how to set up trunks inside of our topology builder, and we'll also see how to configure them from within the control panel. So let's start by opening up our topology builder, and we'll download our topology from the existing deployment. Once again, I'm going to be prompted for the name of a file to use. I'll use my local Carverock Fitness TBXML file, and we'll overwrite it. So from inside of the topology builder, I'll open up my site called Scottsdale and navigate down to the shared components. And you'll notice that I have PSTN gateways and trunks. So if I created a brand new PSTN gateway, and I'll call this one pstn1.carverockfitness.com. As I go through the process of defining my gateway, I define what IP address I'm going to use to communicate over with the gateway, and the next property sheet allows me to define the root trunk. And the root trunk allows me to give the trunk a name. We define the port that we're going to use for communication over with the trunk, the port that we're using on the mediation server, the protocol that we use to communicate over, whether it's TLS or TCP, and we also define the associated mediation server. So this is where when you go in and you define a route inside of your control panel, by defining a root trunk, you're defining which mediation servers will communicate over with the gateway and which port we're going to use to communicate and whether it's secure or not. So if I were to click on Finish, you'll see how it automatically creates that trunk down below. So as you create your gateways, trunks get created automatically. If I go to the properties for one of my trunks that I've already created, you can see that I can redefine those settings. I can modify the settings that I've already defined. Let's close out of there. I don't need to save those changes because I don't need that extra gateway. Now the next thing I want to do is go into my control panel. And inside of the control panel, we'll click back on voice routing. And I want to navigate over here to my trunk configuration. And this is where we have the ability to define the settings for our trunks. Now your trunks can be defined at different levels. So you can define settings globally. You can also define settings at the site or the pool level. In my example, let's take a look at my trunk called Scottsdale. For my trunk, the name is called Scottsdale, and my description, I left it blank. As you can see, the trunk configuration allows me to define the settings for intercommunicating over with your IP-based PBX, your PSTN gateway, or your session border controller. We can also define if your hardware or the mediation server peer supports SRTP, Secure Real-Time Transport Protocol. So for example, if my IP-based PBX or gateway does support SRTP, I can stick with required. We also have the ability to choose optional, and Link will try to use SRTP, but if the mediation server peer doesn't support it, it will use just regular real-time transport protocol. Well, if your manufacturer also doesn't support it, we can go with not supported. If our gateway or IP-based PBX supports referrals, we can select the option to enable sending referrals to the gateway. We can also select the option Enable Refer using third-party call control if you want to have your transferred calls to be media bypassed and your gateway does not support SIP referral requests. I'm going to leave mine just the way it is. If the mediation server peer or gateway supports media bypass, allowing the audio portion of a call to go directly to the gateway and bypass your mediation server, well, then we can select the option to enable media bypass. You would also select the centralized media processing checkbox if you have a well-known or a defined media termination point. So an example of this would be when your PSTN gateway has a media termination point that has the same IP address as your signaling termination point. We can also enable forward call history, and you would normally select this to enable sending of your call history information to your gateway peer of the mediation server, such as your session border controller or your PSTN gateway. Let's take a look at the bottom of the console. You'll notice that I have my associated PSTN usage records. These are the PSTN usage records defined inside of my voice policies. They dictate which trunks are going to be used to route the calls. So as a call is getting routed through the PSTN usage records, they are associated with trunks that will handle the calls. At the bottom of the console, you can see associated translation rules for calling number translation and also for called number translation. When an enterprise voice-enabled user places a call going out through your PSTN lines, the user has the calling number, and we also have the called number. Well, I'm the number that's calling, and I'm placing a call to the called number, an external user. The trunk configuration has the ability to manipulate both of these numbers so that we can represent these numbers in a different format before the call gets routed over to the gateway. So as an example, if I want to take a look at my called number translation rule, if I go to the properties for it, you can see that before I pass a call over to my gateway, I'm going to take any dial string that starts off with the plus. So if you remember, after the normalization of my dial plan, all of my dial strings will have a plus in front of them when they get translated to the E.164 format. So any dial string that starts off with the plus and has at least one digit, we're going to strip off the plus before we pass the call to the gateway. Cancel. And then we'll cancel out of there. Whenever you make any changes to your dial plans, your voice policies, routes, PSTN usage records, or trunk configurations, when you're done making your changes here inside of the control panel, you have to commit your changes. This pushes those changes back into CMS. Now that we've seen all the basics for setting up Microsoft Link's Voice over IP, let's take a look at enabling users for Enterprise Voice. In order to enable users for Enterprise Voice, we can use either the Link Server Control Panel, or we can use the Link Server Management Shell, which has the added value of being able to script. When we enable a user for Enterprise Voice, we have to designate a primary phone number, but Microsoft Link also allows additional phone numbers as well, like for example a private line. When an incoming call arrives at your server, the server maps the number to the user's SIP URI and then routes the call over to the client's endpoint. When you're enabling your users for Enterprise Voice, we have to make sure that users are getting unique numbers within the enterprise. Another important feature that we're going to be using at Coverock Fitness, at least until we get the users shifted over to Microsoft Link, is called Remote Call Control. Remote Call Control enables users to control their private branch exchange phones by using Link Server 2013 on their desktop computers. For example, being able to make an outgoing call, answering incoming calls, or possibly answer an incoming call with an instant message. Inside of Microsoft Lync, a user cannot be enabled for enterprise voice and remote call control simultaneously. Remote call control allows me to maintain users over on the PBX while providing the integration with Microsoft Lync. Let's take a look at a demonstration on enabling users for enterprise voice. In this demonstration, we'll see how to enterprise voice enable a user. So let's open up our control panel. And from within the control panel, we're going to go up to our Users tab. We'll use Bob Christensen as an example. Let's open up the properties for Bob's account. And as you navigate down throughout the property sheet, you'll notice that I have my telephony option, and Bob is currently set up for PC to PC. This means that you can use Microsoft Lync for real-time audio communication internally. So even though Bob is still on the legacy PBX, he can still use Microsoft Lync for making real-time audio calls with other people inside of the organization. Well, what we need to do here is click on the drop-down menu choice and switch him over to Enterprise Voice. You'll also notice that we can use remote call control for users still over on the PBX. We can also disable audio and video. So with Enterprise Voice enabled, we now have to configure a line URI or the telephone number that's going to be used by Bob. So here we'll put in tel, and then we'll put in our phone number, 1-480-227-1400. You'll also notice down below that we can define if we want to apply a user-level dial plan to Bob and if we want to define a user-level voice policy. So as I click on the drop-down menu choice, if you had any user-level dial plans configured within the environment, you would be able to see them and choose them from the list. If I look at my voice policy, I do have a voice policy configured for my executives, so we'll apply that to Bob. And then click on Commit. Now keep in mind that if you're going to be setting up a lot of users for enterprise voice, you may decide to come in through the Lync Server Management Shell and script it. It could save you a lot of effort. Well, I hope you've enjoyed the demonstrations, and we'll see you in the next video.